and we've got Yu from Liverpool, who's going to be talking about a fantastic piece of forecasting work that he's done that is now being used to inform staff planning. So, Yu, over to you. Oh, let me change the timer.
Hello. So I'll be talking a little bit about forecasting any attendance to inform staff planning and decision making. A little bit of introduction, who I am. I'm Yu Qiao, clinical data scientist at the Liverpool University Hospital Foundation NHS Trust. My prior coding experience has been mostly from university, data science program, and a lot of self-directed learning. Very interested in connecting problems with the solutions within organizations in terms of applied science. So that's always been a fascinating part. I joined an HSMA to expand on technical skills and modeling capacities that I currently have, and hopefully using those skills to then be able to further help the organization, staff, and patients through those skills. So you must have heard a lot of news related to A&E in terms of winter pressures, high level of demand, waiting time, and especially nowadays with the limited use of resources as well as financial constraint in some extent. Okay, so that's good in terms of all kind of things that we have heard about, but what is it actually like for patients? I'm going to tell you a little bit story in terms of going to A&E itself. On one particular day when I had an injury, I went to the A&E as a patient. It was bustling with a lot of patients and injuries and everyone else seems to be in pain over there. I went to the front desk, registered myself, sat down, and was there waiting. And had occasional glance in terms of, okay, it's not particularly a great place to be in terms of being in pain, lots of shouting, unrest, and apparently I cannot rest because I might lose my spot if I'm being called on. I looked at waiting time and it was averaging on 8+ hour mark before you are going to get seen. That was very concerning in this kind of environment. I then was able to finally see a doctor after quite some time, and I realized that it's very much so bustling behind the scene, and I'm not sure if the demand at that particular time exceeded the capacity of what's being able to deliver. This might be a particular day, but it can be quite concerning for the patient at any given time. So in order to deliver great care in a safe manner and improve patient experience, something needs to be done. And from our perspective, we would be able to look at informing the A&E management team in terms of how many patients are going to arrive at any given time to help the A&E operation and staffing levels. So what we did is then we went to look at the data exploration in terms of what's there. We found out that our current tool had some limitations as it used only a weekly trend. But the A&E attendance was actually based on daily, hourly, weekly, and monthly, which we also called seasonal trends. We went to then choose a model that would be able to help us in this, something that would be explainable, contained all of these type of trends, and something that's fit for purpose and lightweight. So we chose a multi-seasonal trend decomposition using Lewis model. So what this model does, it breaks down our attendance into tinier and smaller parts that we're able to add in together at the end to give us some results. So it broke down into monthly trends, a 24-hour trends, a weekly trends, and leftover variation based on weathers, some emergencies, hurricane, or different kind of changes. So when we add all of these up together, we are able to create something that will predict on the daily level how many patients are going to attend at the A&E. Well, we got some nice results. We had a 9% difference on average prediction between between the prediction and actual patient attending on any given day. So what does that actually mean? That means if 100 patients were to attend on a day, they'll be predicted somewhere between 91 to 109 patients on that day. It is being classified as a great prediction accuracy. As if we were to multiply this, it's going to be quite a lot of patients. So we had a plan, it's in progress, absolutely fantastic. Except that we have something called Murphy's Law, which is anything that can go wrong will go wrong. Well, we had a sort of storm hit our cruising trip, and all came crashing down, and we could not deploy our model. So we can rebuild a Streamlit app or something similar in terms of application for end users to use. So we came up with a new plan, something that we're integrating this model with our organization plan, with the existing software, and thanks to our team, dev team and data warehousing team, we're able to create something internally to integrate and put this model into use at the daily level. So in the end, we managed to able to create something using Power BI by having the model running in the background and producing the results that would then fed into the Power BI dashboard. And you're able to see that the dark blue line is the actual attendees, and the light line alongside with the range is our prediction model in terms of how many patients will be attending at any given time into AME, which is at best known to be very chaotic and unsure how many patients will be arriving. So this was a great help for them. As we'd say, in terms of the impact, it's currently being used by any staff and management team. It helps them look after 500 patients that come through each day, and this has been in use for 10 months, and within 10 months there are 30 days. So that has helped indirectly about 150,000 patients. So that's wonderful. So how exactly has it helped? It helped our staffing team in terms of resource planning. How many staff need to be available on any given day and hours for the next 6 weeks. Forecasting admission in terms of able to help us to understand how many patients are coming in from A&E and how many patients are already in the hospital, so they're able to communicate between the two teams of discharge team and A&E team to understand at any given point if there's a pitch point and how to escalate that and help to free up some bed spaces where appropriate. They're able to map out some additional benefits in quality improvement projects to support benefit realization in terms of what kind of patients is going to come on, staffing level to able to have appropriate level of staff to ensure patients are being seen in a timely manner, and that we don't lack staff at any given time where there might be a high demand but potentially low supply. It helps making better decisions in terms of when the speech points and the escalations are being made, how many staffing need to be given at any given time and day to help the patients. And then it helps streamline the operation in terms of planning of what needs to happen at the early stages down to later levels of patient flow. It also helps mitigate some risk in terms of having enough staff per patient to ensure that we have sufficient time and use of resources and as fewer waiting time for patient as possible with the given resources available. All these then feed back into a reason why we started, which is giving patient care in a safely manner and helping patient experience of not having to wait as long in agony at A&E. So how does HSMA help us? It has a personal impact in terms of expanding a lot of our skills in modeling and deployment in this context, and able to help us understand what kind of processes we might need and able to have future work as well as the current work in terms of our prediction model to help us in expanding our capacities. And more in terms of organizational-wide improvements is improve our overall capacity in delivering open source tools, which is something that can be seen, used, and adapted by other organizations or individuals as well. So we managed to set up infrastructure that uses R and Python to deploy and for use for our colleagues. Improved capacity and support wider organization and resolving different kind of challenges that might not be able to resolve otherwise using our other tools. And more automation tools available for now. The next step is to publish this into GitHub and also future projects in prediction tools and natural language processing tools in different kind of areas. And very big thanks for Dan and Sami in delivering the HSMA program. It has been invaluable. Thank you.
Very much, Yu. Fantastic presentation, and really, what a wonderful example of these kind of skills being put to real use. And I loved the sort of personal reflection, really bringing the sort of patient experience into focus there, and showing how these skills can transform that, which is ultimately why we run HSMA and why we do this kind of stuff. So fantastic! Thank you very much, Yu.